Okay, so the warm-up is just, the instructions are to factor completely. And today is definitely the heaviest day when it comes to factoring because it's multiplying and dividing, okay? We will continue to factor a lot in this unit, but today is going to be the heaviest when it comes to factoring. Next class, we're throwing kind of another spin on things, but that's not the problem. That's not today's problem, so let's just focus on this. When we say factor, okay, I need you to understand there's lots of different types of factoring that we can do. GCF is always going to be something that we check for very first thing, and sometimes that's all you can do is take out a GCF and you're finished. We need to know what to do with trinomials, which are 3 terms. We'll see some of those on here. We've got easy trinomials when A is 1. Those we need to be able to do in our head quick. When A is not 1, we need to group. So you could potentially do easy or grouping. And then there's also a couple patterns. We have difference of squares, DOS, and then the one that the video talked about, which was sum of cubes and difference of cubes. So SOC, DOC. Difference of cubes and sum of cubes. And we will review those on here. The cubes patterns are not super prevalent in this, but those first 3 are very, very common. Okay, and the faster that you are at these, the easier these problems really can be. I mean, ultimately, if you are really good at factoring, what we're doing today is not that much. But if you're still struggling with that, it's a lot. They look overwhelming, but we'll just break them down. So the first thing, the flips lesson did go over this, and I hope that factoring by grouping was not terrible for y'all because I already have y'all factor by grouping most of the time anyways. We haven't really seen it with 4 terms, but it's not that bad. But remember, your first step is always to check for a GCF. So let's look at number 1. Do we have a GCF in this problem? I wouldn't take out a negative unless the highest exponent has a negative, okay? So, like, I wouldn't get in the habit of doing that unless your very, very front number has a negative there. There are times where we will do it, but I wouldn't do it here. But the GCF is 2x on this problem. Very good. You can take out a 2. All the coefficients are divisible by 2. 2 is the smallest number of the coefficients, so that's what I would start with. It's not going to be bigger than the smallest number. And then as far as the x's go, if all the terms have an x, you take the lowest power out. So your GCF is going to go in the front, so let's just bring that out there. And when you're technically factoring that out, you're dividing out a 2x squared. So what's left inside? If you take out a 2x. X to the 4th minus. Very good. Okay. And so with the GCFs, again, I normally drop them down, put them in a part of my final answer, and I'm going to kind of ignore them for a little bit. Okay. We're not going to need them right now. However, it is a part of your factored form. Okay. We're not solving anything either. Solving is all going to be next week. Everything for this week is going to be about simplifying, just shrinking it down, making it more simple. So you're not going to be getting x equals for that. Okay. All right. Now when it comes to 4 terms here, we are going to group these. So we're going to look at these 2 and these 2. And again, this step should not be super new for y'all because this is how I always teach factoring. So what can I take out of x to the 4th minus 2x to the 3rd? X to the 3rd. And what's left inside? X minus 2. And the other group, 8x minus 16, I can take out a 8, and I'm left with x minus 2. Okay, did we group it correctly? Yes. How do we know? Because they match. So that will be one of my factors, x minus 2. And then the guys in the front become my other, x to the 3rd plus 8. Is x minus 2 fully factored? Is there anything else we can do with that? X minus 2? X minus 2 is done. So I'm going to go ahead and put x minus 2 down here. There's nothing else left. We're not solving. It's just there's no GCF. There's no special pattern. But x to the 3rd plus 8, is that fully factored? No. That is what we call a what? Sum of cubes. SOC. Why did I say sum? What's the sign in the middle? A plus. X to the 3rd is a perfect cube. 8 is a perfect cube. How do I know that? Because 2 times 2 times 2 is 8, and x times x times x is x to the 3rd. Okay? So that is a sum of cube. That was in the video on how to do this. Now this, did they say anything about, in the video, did they say anything about SOAP? Same, opposite, always positive. Did they do that?
No.
I don't remember. I didn't watch that video all the way through. But here's what the SOC and difference of cubes patterns are. We'll write them in. And again, this isn't as prevalent, so I don't want you to stress as much with that. I will let you know if you need to have this memorized. Right now, I do not believe that you need to, but I will let you know if you do. But what it means is if you have, and what's nice about this pattern is it works with subtraction and addition. But if you have two perfect cubes being added, okay, and that's one thing that I don't know. I feel like people were a little bit confused. This would be like what you're trying to factor. So like this is that step right here. It's going to factor into, the pattern goes A plus B is your first factor. And then the next one is A squared plus, oh no, not plus, sorry, it's minus. Minus AB plus B squared, okay? And it's just a pattern, and I'm going to kind of explain what all that means. I'm going to explain when I said SOAP so you can understand what I'm talking about here. So the SOAP stands for, if it's a sum in the original, what you're factoring, that means your first factor is going to have the same sign, same, so plus and plus. The next sign is going to be opposite, and then the last sign will always be positive or always plus. So when you look at these factoring patterns, they truly are the same, except for if it's originally a plus sign, then your signs will go plus, minus, plus. If it's originally a minus sign, they'll be the opposite of that. So you don't have to get caught up in like the A's and the B's and all the things. They're going to be mostly the same. It's just the signs are going to change. So here's what these are. A squared plus AB plus B squared. Same, opposite, always positive. So now figuring out what like A and B and all those things are, A is just what is that cubed root? What is that perfect cube? B is the first thing. B is what's the perfect cube of the second thing. So I kind of will label them like to the side right here. So if I'm factoring x to the third plus 8, I'm factoring something that looks like this. Okay, so my answer is going to look like this. It's going to be a binomial, and it's going to be a trinomial that doesn't factor. Do not try. It's not going to if you're using this pattern. All right? So what is A going to be? What is the cube root of x to the third? X. Okay? What is B going to be? What's the cube root of 8? 2. Okay, really, that's all I need to know. And now I'm just going to follow the pattern. So I'm focused on the sum. My first factor is going to be A plus B. Well, there it is. X plus 2, same sign. My next factor is going to follow this, A squared. Well, what is x to the second power? X squared. Minus, opposite sign, A times B. What is 2 times x? 2x, always positive. B squared, 2 to the second power is 4. And this is fully factored. Okay. Okay. If that's not what you did, that's okay. We're doing it right now. I don't know.
Whatever. I was trying to explain this to me, and I just was.
Okay, let's skip down. Let's try 5 real quick. Let's try 5 real fast. Let's look at 5. Okay. Listen. If I got it up here, but go ahead and look at 5. This is just straight. If it is a binomial, is either going to be GCF and done, difference of squares, or sum or difference of cubes. So look at number 5. Y'all, if the power is to the third, do not try difference of squares. You're probably thinking sum of cubes or difference of cubes here. So is 27 a perfect cube? Yes. What's the cube root of it? Yes. 3. So I'm going to go ahead and label that in this case. A is going to be 3x. What is B going to be? What's the cube root of 64? So as far as the negative signs, when I worry about the sign is important because the sign is going to tell me what order these have to go in. But when it comes to picking A and B, just go with like cube root, like just the numbers. I would ignore the sign for that. But now I can look at it. Okay, this is a difference of cubes because there's a minus there. So I'm going to put DOC. It's a difference of cubes. And I'm following, let me see if I can move to where you can still see me writing. I don't think you can. But I'm following this right here. This is what my factorization is going to look like. Okay? So since it's a difference, I'm going to start with same sign. So I'm going to take cube root 3x, same sign minus cube root 4. That's my first factor. Okay? Now be careful here because we've got some coefficients, so we have to watch out. So open up your next parentheses. The next term is a squared. You have to square the number and you have to square the variable. So what's 3 squared? 9, and then x squared is x squared. Make sure you square that coefficient as well because sometimes that gets forgotten. So there's my a squared. My next sign will be opposite because I do same, opposite. So my next sign is going to be a plus. The middle term is the product of these two. So what's 4 times 3x? 12x. The last sign is always plus or always positive. 4 squared is, this is it. You are done. You have factored this. No more. Yeah. So as far as the, yes and no. As far as the, because of the way the factoring pattern works, the signs in between are going to determine this sign, and this sign. So don't really worry about the number. Like when I get A and B, I'm strictly just looking at the numbers, like the absolute value of those. I apply the signs when I do my like same, opposite, always positive, if that makes sense. Okay. Look at 6 real quick. Right now, this isn't anything, but what does this have on number 6? It has a GCF first. It does have cubes, so that's kind of like a hint to me, hey, I'm going to be using my SOAP formula. But it does have a GCF, because right now, 16 and 2 are not perfect cubes. What is it GCF that they have in common? 2. So if you bring this out, it ends up looking like this. Drop down the 2. And then is 8 a perfect cube? Yes. Is 1 a perfect cube? Yes. Now you can do the AB thing.
The video didn't explain, and that's why I was confused about how to get it. Like, I probably should have known that I could just GCF it, but like, I didn't think about that.
You just kind of like divided things and said, here's numbers, and he'd erase them. And then
Really
started
something else.
My apologies.
But I think it's hard to find a good video.
All right, so here's this one. Again, so you gotta watch out for those GCFs, but that was a review of sum and difference of cubes. Again, it's a pattern that we need to be able to recognize. It's not as prevalent in these because these trinomials, like, you really can't do anything with, even though they look like you should be able to do something with, you cannot. And they don't simplify any more than that. What you're gonna see more of today in the notes and stuff is going to be problems like the other ones, but I did want to review that pattern with you. Hopefully that helps you kind of thinking the A-B thing and then remembering the same, opposite, always positive. But going back to, we'll do 4. We'll do 4 next. Again, the first thing you're always looking for is what? Any factoring problem ever. You're looking for a GCF. Do we have one here? Yes. What is it? Yes. 3x. So 3x goes on the outside. And then you write what you're left with. What are you left with here?
X minus
16.
Okay. 3x is fully factored. Drop it down. Don't forget about it. It's part of the answer, but there's nothing else we can do. X to the 4th minus 16. That is not fully factored. Okay. And this is a pattern that we have seen before. We just haven't seen it with an x to the 4th, but it still follows this pattern. Do y'all remember what my favorite factoring pattern is? No. I'll remind you. Difference of squares. Okay. So for this one, sum and difference of cubes are binomials as well, but they have to have that to the 3rd power for that to work. With squares, difference of squares, you have to have even patterns because they have to be I don't think square rootable is a word, but I'm probably going to say that a couple times today. They have to be perfect squares, aka square rootable. Now, difference of squares only works if you have a minus in between. And we have seen difference of squares before. We just haven't seen it with an x to the fourth, but it's not that crazy. So that's the pattern that breaks into square root plus square root minus square root. That's why it's my favorite. It's very easy. It's going to come up a lot in this unit. Okay, because they are easy to just factor really quick. So that's how that works. So we are going to factor this into what times itself is going to give you x to the fourth. What is the square root of x to the fourth? We really just did this. The square root of x to the fourth, that is the same thing as x to the 4 over 2. And 4 over 2 is 2. So this factors into x squared. Okay, so x squared. And I said we're going to do the plus one first because I like positives better. What is the square root of 16? 4. Notice, I did not say negative 16. I need that to be a minus. That's not going to trip me up. I'm going to just take the square roots of the numbers just like I did with this factoring pattern over here. This is one of my factors. Square root plus square root. What's the other one? Square root minus square root. I can't do that right now because I have to do square. I'm factoring this. That does not factor. We are going to keep going. There's not a fourth power pattern, factoring pattern. Okay? But some of that is going, just give me a second. Okay? All right, x squared plus 4. Those are two perfect squares being added. Hear me out. You cannot do anything with perfect squares that are adding. They are done. This is done right here. So put this right here. You just can't do it. You're going to get imaginary solutions. And unless you want to deal with i's, I don't think you want to go down that path. Okay? Sum of squares is not a thing. Now, this guy, x squared minus 4. Okay? That's a binomial. That's a minus. X squared is a perfect square, and 4 is a perfect square. This is another difference of squares right here. Okay? This is the one that you've seen more. I expect you to be able to recognize x squared minus 4 and know what to do. How does that factor? It's the same thing. Square root plus square root. Square root minus square root. X plus 2, x minus 2. So, Matthew, that is there. But the x squared plus 4 has to, that doesn't keep going. So that's why you kind of have to take it in 2 steps instead of 1. Yeah.
So if the difference of squares has the subtraction sign,
Try number 2. GCF, group it, and watch for some of those patterns. Ready, set, go. So at this point, there is a GCF on this problem. You technically do not have to take a GCF out first and you can still factor. It is easier, though, to take it out first. If there is one, highly suggest that you take it out first so that way your factoring will be easier. And it didn't have a numeric, but it did have a variable. So I took out an x squared, then I was left with 4 terms. So then I grouped. We've been grouping. This should not be news to you guys because we group all the time. So then I take out my GCF of my first group. Write what's left over. Take out GCF of second group. Write what's left over. And then I go from here. X minus 1. Is there anything else you can do with x minus 1? No. Put it in your final answer. It's fully factored. 4x squared minus 25. Okay? Is that fully factored? No. Because 4 is a perfect square. X squared is a perfect square. 25 is a perfect square. And they're subtracting. So what is that known as? Difference of squares. How does that factor out? 2x plus 5. And is it okay if you put the minus 1 first? Sure. Don't care. Now you are done. Okay? Now, the last one is just a plain old trinomial, but it's not easy factoring. We're going to review this one more time, and then we're actually going to get into the main idea of what we're doing. Is there a GCF on this trinomial? No. Quiet down. Quiet down. No, there's not a GCF. So we're going straight to the number puzzle. Okay? What goes at the top of the number puzzle?
Negative 42.
Negative 42, because it's 6 times negative 7. What goes at the bottom?
Negative 19.
Okay, we need to be able to do this in our head without a calculator in less than a minute. What are two numbers that multiply to be negative 42 and add to be negative 19?
1 and 2.
Thank you. Okay? Are we, and I'm talking loud because I'm tired of this happening, are we going to write this as x minus 21 and x plus 2?
No.
No, we are not going to do that because of what?
Because it's not easy.
A
factoring.
value is not 1. It is not easy factoring. Stop making that mistake. You're going to have to group this. So you're going to write it 6x squared. What do y'all want to put next to 6x squared?
21.
Okay?
I bet y'all think it's probably easier.
I already committed in ink, but you could, I would do that. I would do that too, but I just listen to the front. It's fine. It's fine. It's fine. It's going to be the same either way. Okay? So then, what do I take out? 6x squared. Hey, are you having a conversation about factoring? I don't think so. What can I take out here? And what's left?
2x.
X minus
The second group, what can we take out? Good. If you can't take anything out, this is like the one and only time that we will take out a 1 or a negative 1 because that's just all we got to do. So they match. What are my factors?
3x plus 1.
Very good. Is it okay if you wrote them in a different order than I just did?
Sure.
Sure. Okay. So honestly, this is not easy factoring, but it's way easier than everything else on this page. Okay. Now we're going to get into actually what we're doing.
I'm done.
No, we're not. Okay. So, real quick, no, we don't have time for a 5-minute break. Listen while I'm talking about the calendar. This is your break from the problems on your paper. What we're doing today, stop. What we're doing today is we're going to talk about how to simplify very briefly. We're only going to do like 2 problems of that. And we're going to talk about multiplying and dividing rationals. Okay? Next class will be adding and subtracting. Believe it or not, multiplying and dividing, while the factoring is worse or heavier, and this multiplying and dividing are far easier, in my opinion, than adding and subtracting. So that's why we're doing these first. Adding and subtracting, you get a little break on the factoring, but there's another aspect that is a problem for next class. We will take a break in between at the end of the week and have a homework check and kind of a day where we just like put everything together and do a CFU, and then we get into our solving unit. So all these first 3 days are all going to be about simplifying. There is no equals. There is none of that going on. This is just about simplifying and making it simpler. And this is going to be its own test topic too when we get to the test in a few weeks. Speaking of your last test, I have them graded, but I still have like 8 people who have to make it up, so I'm not ready to pass them out yet. If not next class, then maybe Friday, okay? So you can see those there. But you can check hack. I don't want to talk about those right now. All right, here we go. Page 2. Page 2. It's time to get focused. Remember my lecture at the beginning.
This is what I'm talking about?
Right now. Okay? A rational expression is simply a quotient of 2 polynomials. So I've been saying rational and fractional are kind of your synonyms. Well, here we are. So you're looking at fractions. However, your fractions are going to be polynomials. Polynomial over polynomial. And we're going to be doing a lot of operations with them. We're going to start just by simplifying a rational down, like one at a time. So if I look at example 1 and example 2, we're not doing any sort of operation. It is just strictly, hey, here's a polynomial over polynomial, simplify it. When it comes to simplifying one at a time or even multiplication and division, you are just basically trying to factor the numerators, factor the denominators, and look for common factors. So I'll do example 1, you will do example 2. These are both easy factoring, so chill out. Okay, n squared minus 16n plus 63. How does that factor? It's easy factoring. Why?
N is one.
The a value is 1, so I know this has got to be n times n right there. What are two numbers? Don't scream. Just quietly think to yourself that multiply to be positive 63 and add to be negative 16.
9 and something.
Anybody got it? What kind of 9 and 7? Negative 9, negative 7. Why can I just slide those numbers in there like that? Because the a value is 1. We love that, okay?
Awesome.
Now, let's look at the denominator. N squared minus 2n minus 35. Well, also easy factoring. I know I'm going to start with n times n. Still doing a number puzzle. I'm trying to get to negative 35 and add to be negative 2. What kind of 7 and 5? Negative 7, positive 5. Okay, so we factored everything out. Now we're going to look at the factors, and if there are any matching factors in the numerator and denominator, what is anything divided by itself? 1.
Oh my gosh.
We say cancel out, but it's really they are simplifying to 1. So this and this are going to simplify out. The other two, nothing happens. So what's your simplified form? N minus 9 over n plus 5. And this is your answer. Okay? That's a big bulk of what we're doing today. Okay? So try example 2.
Well, I feel like example 2 is going to be harder.
Example 2 is not going to be harder.
Example 2 is easier?
It's about the same. The thing that makes these complicated is that they involve a lot of factoring. It's not necessarily that it's rocket science. It's just a lot of work. Okay? All right, so how's the top factor? X what?
X minus 2.
Oh, wait, no, that was
Minus 2 plus 3. Plus 3 minus 2, whatever. And then on the bottom it's...
Plus 5 plus 3.
And again, the order that you write your factors, it's when you factor, you're writing it as a product. Multiplication, it doesn't matter, okay? Do you have a common factor that will simplify out here? X plus 3.
So it's just going so.
So what's left over?
X minus 2 over X minus 1.
X minus 2 over X plus 5, okay?
Wow, very light.
So here's the idea. This is not even, we haven't done an operation. We've just simplified. But this idea of simplifying common factors, 1 in the top, 1 in the bottom, that's ultimately what we're going to be doing. But now we're going to get into the actual operations of multiplying and dividing. So we kind of reminded you right here, like you're following the same fraction rules. And if you remember back, I don't know when fractions are introduced, elementary school's a blur. But multiplying and dividing fractions truly is easier than adding and subtracting. And it's because of the common denominator, which is a Wednesday problem. But for today, what's nice about once you get it to a multiplication problem, all you do is you end up just multiplying everything in the top, putting that on the top, multiplying everything on the bottom, putting that on the bottom. The only thing that's different about dividing is that we don't divide fractions, so we do our keep, change, flip. Do y'all remember what that means? So if you're dividing two things, then you're going to keep the first fraction, flip the second one, and then it's keep, change, flip. Keep, change the sign to multiplication, and then flip the second fraction. I wrote that out of order. Okay? Keep, change, flip. So as far as steps for this, let me see if I have room at the top. I'll write them at the top here. But ultimately, what we're going to be doing on these problems is paying attention to, is it multiplication or division? If it's division, we're going to have to do keep, change, flip, and turn it into a multiplication problem. And then we're going to do the same thing. Everything's going to get factored all the way down. I'm going to write this down in a minute. I'm just telling you. We're going to factor everything. We're going to multiply across. And when I say multiply, I don't actually mean FOIL. We're just going to write all of our factors side by side by side. It's basically going to turn into one big fraction. And then we're going to simplify out. That's the big picture. Okay? So here we go. I'm going to put step 0. And I'm going to write keep, change, flip. I'm going to write it right this time. Keep, change flip. And that's only if it's a division problem. Okay, so that's for a division. Don't do this if it's multiplication. That's why it's step 0, because you don't always have to do it.
Don't do that.
Step number 1, factor everything. Factor everything. All numerators, all denominators, all factoring patterns are allowed. Okay, let's just start example 3.
Isn't this multiplication?
Yes, it is. Okay, so example 3. How do you know it's multiplication?
Because there's a dot.
Multiplication dot. So do we have to keep change flip here?
No.
No. Check. Moving on. Okay, factor everything. All right, let's look at this. One thing at a time, people. The first numerator, x squared minus x minus 2. Is that easy factoring?
Yes.
Yes, it is. What does that factor into? X plus 1, x minus 2. Check 1 of 4. Someone get the door. Okay? All right. The denominator, 2x squared minus 3x minus 2. Is that easy factoring? No. Why?
Because the A value is
You
not
got an A right there.
Because the A value is not 1. Oops, I didn't mean to write that there. So how do we have to factor this? We have to group it. I'm going to do this one with you. What goes at the top of my number puzzle? What goes at the bottom?
negative 3.
What are the two numbers here?
Negative 3.
-4 and 1. Okay?
When's the top? Oh, I'm stupid.
Because it's 2 times -2. 2x squared minus 4x plus 1 minus 2. Okay, so we have to group this because it's not easy factoring. By the end of this, you should be so good at factoring, it's scary.
I'm afraid.
Okay? I factored 2 of 2. Don't try to cancel anything out just yet. You can probably already see that there is going to be some stuff, but I kind of want to talk about it as a whole picture here. Okay? All right. What about the bottom denominator, x squared plus x? How do you factor that? G, C, F
Yeah, X.
times
It's
x plus 1. Okay? All right, now go factor 2x squared minus 5x minus 3. It's not easy factoring. You might need to go the side over here. Go over there and do it. So again, I had to pull these two polynomials to the side and kind of factor them off to the side because they were not easy factoring. However, the top guy was, the next guy was just a GCF. It's going to just vary. You're going to see all the types of factoring. It just depends on what you got. But I promise you, you're going to have to factor by grouping on your test, as well as all the other easy stuff. So at this point, yes, we're getting there. At this point, we did not have to keep change flip because it was not a division. Do you have a question? Factor everything. And then technically, oops, this is step 2. Technically, when you have it as a multiplication, I kind of like to just write it as like one big mega fraction, okay? Because technically, when I'm multiplying all the way across, I'm just multiplying all those factors on the top, all those factors on the bottom. I'm not actually multiplying them. I'm really just writing them side by side. I like to write it as one huge fraction, okay? So that's step 2.
Mega fraction.
Write as mega fraction.
Sounds like a change.
And then our final step is going to be to simplify / cancel out. Everybody likes to say cancel out, but the math people don't like that. Cancel common factors. When they're canceling, what is it simplifying to be? 1. Okay, so that's why they go away, but they're becoming a 1. It is 1 in the top, 1 in the bottom. Okay, so an x plus 1 right here can go with a X plus 1 right here. Simplifies to 1. Anything else?
The X minus 2's.
The X minus 2's. 1 and 1.
2X plus 1?
The 2X plus 1. 1 and 1. Anything else?
No.
So what is left on the top?
X
Minus 3.
X minus 3. What's left on the bottom?
X.
There's your answer.
I can rock with it so far.
Okay?
I can't.
That's basically what it is. It's just a lot of factoring. But you are allowed to go through and you can go across, and that's why I like to write it as one big mega fraction, so that way I can see kind of the cross where things go. But that's what we do. Okay? Let's try a divide.
I don't like mega fraction.
This is a division. There's a division sign there. So, here's what I do. I'm lazy, and I don't like to rewrite a problem 800 times. So, I'm going to keep the first fraction the same. I'm going to go over here. I'm going to change to a multiplication, and I'm going to go ahead and flip this guy. Okay? Watch what I'm doing. X squared plus 2x minus 8 goes at the top. X squared minus 5x plus 6 goes at the bottom. Scribble that out.
That's like,
I just don't like to rewrite the same problem 800 times over. So I just kind of flip it, change it to a multiplication, and then I scribble it out to save myself. Now,
what's going on with this?
don't look at it. Now we're going to factor everything. All of these are easy. 4 factorings. Go. What's your question?
I'm doing.
Okay, so factor everything. That's okay. There doesn't have to. There's only 2 that cancel. I got more. I think I'm gonna have more. There's only 2.
I thought it was X plus, wait.
I didn't get X minus.
I had 3. I got X plus, wait, X.
I got
the
X plus 2 and
4,
one.
the
I got
X.
3 to cancel that.
Oh wait, this is supposed to be x plus 2, x minus 3, right?
Yeah.
Oops. Minus plus. So there's only.
I
No,
also got a 6 in there.
there's. I don't think there should be a 6 in there.
Okay, I don't think anybody got the bottom right.
X plus 2 over X minus 1. Right?
No, this should be.
Negative 6 and 1.
It's X plus
Wait,
2.
what about the 6 and the minus 5?
It's X. You're right there.
That has to be minus 2 and minus 3.
Is it not a negative 6 and 1 on the
No.
Oh, yeah.
So it's X plus 2, X minus 1.
At this point, now we. Hey, quiet down. Mega fraction. Solve multiplication. Simplify out what you can. Hey, chill. Chill. I don't think this is that funny.
Dislocated his shoulder again.
Aiden?
I-
So 3 things. 3 things simplify out. Careful with the 6's. I know, it's confusing. X squared minus, I messed it up. X squared minus x minus 6. X squared minus 5x plus 6. Just be careful with those negatives. It's the 2 and the 3 and the 6 and, yeah, I know. It's a lot. So this simplifies to x plus 2, x minus 1. Because that's all that's left over. This guy and this guy. Okay? What? You have to get a product of positive 6 and a sum of negative 5. So you have to have 2 negatives. I know. I hate that trinomial. Okay, flip. Still going. Still going. Okay. For some reason,
For some reason, this problem's good.
no, this is missing. Hold on, let me find it.
70.
Oh my god.
Chill out. All right, this is supposed to say 60 right here.
Oh my god.
Even better.
Even better.
Okay. Okay. We got to get through this.
We need to do it.
Why do we need to know this? Pre-cal. Okay.
Why do we need to do it?
I don't know. Talk to the state of Texas. Okay, so here we go. When it comes to factoring these, again, these are going to take a couple steps. So don't freak out. Let's talk about the first numerator. What's the first thing we always look for when we factor? Okay, what do we have a GCF of in the first numerator? Just focus on one at a time. 3x. Okay, so then we're left with x squared minus x minus, oh, there's another 6, my favorite. Okay, So we'll factor that in a minute, but after you take out the 3x, it becomes easy, doesn't it?
Sure.
Yeah.
Oh,
X squared minus x minus 6. Okay? Do y'all want to finish factoring that, or do you want to, what do you want to do?
Yeah.
Because there's kind of like 4 things.
Just leave it.
We're going to have to factor it all the way, but we'll leave it for now. Okay, 7x minus 7. What do you factor that by?
7x.
Okay, that's done. 14x minus 70x plus 56. There is something in there. Greater. Greater.
About 7.
You can take a 14 out.
14.
And that leaves you with x squared. 5, yeah. Mm-hmm.
Oh, -4. And -4.
Well, we're just factoring in steps right now. So now we need to go, we've taken out GCFs. We're done. This one's done. But now we need to keep going. So I'm going to do another fraction bar times a fraction bar. I'm going to go ahead and write this being done. I'm going to go ahead and write my GCFs on the outside. But then now I've got to multiply those 3 trinomials. But when I took out the GCFs, they became easy factoring. So they're not super duper terrible. So x squared minus x minus 6. I think we just did this one. Is this the one I messed up on? It's supposed to be x minus 3, x plus 2?
Yeah.
Yeah.
Because we got to get to negative 6. But we ought to add to be whatever, negative.
I thought it would flip.
No. No. I don't think so.
This other one,
That's a next.
It flips when x equals it.
you flip it when you're solving. We're not solving today. Okay, all right, 2 numbers that multiply to be positive 4, add to be negative 5.
That's like
It's -4,
Mm-hmm. Multiply to be 12 and add to be negative 7.
That's going to be a little free for whack.
-4, -3.
Okay, mega fraction.
Mega fraction.
So the first thing I'm going to do is find the binomials that simplify out, but we've got some like GCF numbers to work with here, so we got to hang on about those. So let's go ahead and find our common factors. I've got a x minus 3 up top and an x minus 3 on the bottom.
Let's go.
I got an x minus 4 and an x minus 4,
X minus 1,
x minus 1, x minus 1. Okay. So now I need to look at the numbers. Here's this 3x right here. Think of that as like a 3 factor and an x factor. Is there any other like just plain x's on the bottom? So that x isn't going to be able to do anything. That x is going to stay. I'm going to circle it because it's going to stay. X plus 2 is going to stay. Now when it comes to the numbers, think of it as like you're doing fractions. Okay? You're trying to see 3/7 times 14/5, but you can kind of simplify within there. Can 3 reduce with a 7 or a 5? No. Can 14 reduce with a 7 or a 5?
Yes.
Yes. 14 and, okay, what do they both divide by? No. They can both divide by 7, but it's going to become 2 over 1, which you don't have to write the 1. And then, could I do anything with 2 and 5? No. So let's circle what's left on the top and circle what's left on the bottom, so that way we can kind of see what we're looking for here. And we've got 3 times 2, which is 6, and a factor of x, and a factor of, and then what's on the bottom? And we're done. I think there's ones like this on the homework, so we need to make sure we go over this. Okay, there's 3 things, 3 fractions, 3 rational functions. The first two are being multiplied, the last one's being divided. The first thing I'm going to do, I'm going to just flip the last one, and then I'm going to mark it out. X squared plus 5x minus 6. X to the third minus 2x squared plus x. And then scribble it out. So then it just becomes one big multiplication, and the only thing that is going to be different is that instead of factoring 4 things, you are now factoring 6. Okay? Okay. A lot of times in a row. X squared plus 2x minus 3. Easy factoring. What does that factor into? Yeah, positive 3 and negative 1. Okay? On the bottom, what's the first thing that we need to factor? GCF. Can I do this in?
What?
Well, no, I'll just keep doing what I'm doing. X times x squared plus 9x plus 18. That's going to keep factoring. Okay? All right, what about this next guy? 5x squared minus 5x to the third. 5x squared times 1 minus x. Very good. Okay. X squared minus 5x plus 4. X. X squared plus 5x minus 6.
That's gonna be
No, it's 1 and negative 6.
Yeah, negative 1 and 6.
Yep.
And then the last one has a GCF of x. Yeah.
The negative 5x cubed, can we take a negative out?
I'm going to. I'm going to. You're one step ahead of me. Okay, so I'm going to write what is done at this point. And again, I know it's a little tedious writing all this.
we're writing that all in.
I'm going to, because they're not all done. I'm just going to write the ones that are.
Why do I feel like I'm on a cruise ship right now? Like I'm seasick.
Dog, I'm not getting any
I'm seasick right now. But I'm
Okay, so notice I rewrote these 3 and just these 3, okay? Because these bottom 2, I got to keep factoring. Let's go ahead and do those real quick. I've got the GCF on the bottom. And then x squared plus 9x plus 18. Multiply to be 18, add to be 9. 6 and 3. Okay. All right. Over here, we've got x squared minus 2x plus 1. So that's got to be x. Oh, and a GCF. X minus 1, x minus 1.
yes.
Now, let's talk about this real quick, okay? Having a factor of 1 minus x, if you look at all of our other factors, they all start with x, okay? And we want those, if we're going to like simplify stuff out, we need to know what's going on there. So what is 1 minus x the same thing as?
X minus 1.
No.
Negative x plus
Plus 1. And then if I take out a negative, then what does it turn into?
I went down to my feet.
Okay? So I think you have to do this on example 8 as well. So I wouldn't be surprised if you have to do it there. But if you've got them out of order like that, like your x is not in the first place, switch them and then take out a negative. But you already have the 5x squared there. So really you have a negative 5x squared times x minus 1.
So why
Because, okay, here's the thing. When it comes to simplifying your stuff down, they have to be matching factors exactly. A 1 minus x and an x minus 1 are not the same thing. Okay? Pluses, it doesn't matter. But minuses, they are not. So I switch the order. I took out a negative because I'm trying to make it to where my factors are all set up where they have a positive x first and then whatever. But I had to factor out a negative, and there was already something factored out, so it just made this guy become negative. Okay? It's not crazy. It takes a little bit of thinking. Okay? All right, mega fraction. Here we go.
Mega.
Just one piece at a time, you guys. Don't try to do it all in your head. There's absolutely no way you can do this. Okay? All right, x plus 3. Can I take an x plus 3 out on the bottom? All right, that's gone. What about x minus 1? Remember, it's 1
There's a lot of them.
for 1. 1 on the top, 1 on the bottom. Settle down. 1 on the top, 1 on the bottom. It can only go 1 for 1, though. 1 on the top, 1 on the bottom. What about x plus 6?
Oh my gosh.
Goodbye. Goodbye. Yep. Okay, all right, look right here. This negative 5, I'm going to do this in 2 steps so that way you don't get too confused, but you can do it in one. Negative 5x squared over x squared x minus 4. I'm doing this in 2 steps just so you can kind of see it. So this is left, this is left, this is left, and this is left. On the bottom, since I have 2 x's, I can, in fact, write that as x squared. But I have on the top a negative 5x squared, so those technically are common factors. So you could have said, hey, there's 2 goes with 1, 1 goes with 1, right there. Or you could take them out here. But what is your final answer? Done. Okay, let me pass out your homework. We will maybe come back to these other ones as a warm-up. Maybe not. Let me make sure there's nothing missing on these. You do have to do the switcheroo thing with the sign on number 8. And then number 6, I don't think there's any numbers missing. Do you want me to work these out and put them on Canvas?
Yes.
Okay, I'll get them worked out and on the Canvas key. If we do them as a warm-up, great. But there are some homework problems, so let me pass those out. I'll get 6 worked out, but when you have a binomial squared like this and like this on the homework, my advice for that, there's really no factoring to do here. So let me just show you how I would do this. If it's x plus 1 squared, I would write it like this. X plus 1 times x plus 1. The reason why I would separate it out like that is for when you're doing your simplifying, it's only a 1 for 1 thing. So this is kind of nice because you don't have to factor anything, but I would suggest writing it side by side, and that happens on number 1 here. You are only doing 1 through 6 today, okay? Only 9.1. And I do have an answer key with work to that if y'all want to come check that as well. Your homework check is going to be Friday, and it's going to be 9-1 and 9-2. So you're going to have to do homework between class to class. Okay? This is not something that you want to just try to squeeze in at the last minute because it's not going to be a good time for you. All right? We've got to make sure we know the skills because we're throwing more and more at you each day.